Hey everyone, and welcome to this explainer. If you've been anywhere near the internet, the news, or, even a water cooler lately, you've definitely noticed that artificial intelligence is literally dominating the conversation. But let's be totally honest here. We're all being absolutely bombarded with this complex, layered web of tech jargon, and it can feel incredibly overwhelming. Large language models, deep learning, transformers, neural networks, it kind of sounds like a completely foreign language, right? So my goal today is to cut through the noise and demystify this vocabulary for you. We're going to unpack these concepts logically, step by step, so that by the end of this, you'll walk away with a crystal clear understanding of the modern AI landscape. All right, let's dive right in. To start, we really have to ask the most fundamental question of them all. What actually is artificial intelligence? Take a second and think about what immediately pops into your head when you hear those two letters, AI. Because for decades, pop culture has basically fed us a very specific and, frankly, a wildly misleading narrative about what this technology actually looks like. We tend to picture traditional robotics, right? The creepy metal boxes with the glowing red eyes or humanoid machines marching down the street. It's a fantastic sci-fi trope. But it's time to completely shatter that myth. Real artificial intelligence, the kind that's literally reshaping our world as we speak, doesn't look like a physical robot at all. It actually consists of super smart digital brains. We're talking about highly complex programs and algorithms running on massive, invisible computer servers in the background, simulating human comprehension, decision-making, and learning.
But look, AI definitely isn't some overnight phenomenon. We can actually trace this back through a long, steady march of progress. Way back in 1950, mathematician Alan Turing first conceptualized the whole possibility of AI with his famous Turing Test. Then, fast forward to 1997, and you've got IBM's Deep Blue processing something like 200 million moves a second just to beat a world chess champion. In 2011, Apple puts a virtual assistant named Siri right into our pockets. And then, boom, in 2022, OpenAI releases ChatGPT, which really kicked off the massive surge we're living through right now. The crucial takeaway here is that today's AI boom, it's built on decades of these foundational milestones.
Section 1. The AI nesting doll. Peeling back the layers.
So, to really make sense of the actual technology behind all these milestones, I absolutely love using a Russian nesting doll framework. People throw around terms like AI, machine learning, and deep learning interchangeably all the time, but they actually fit inside one another, moving from the broadest concept down to the most specific mechanism. So picture our outermost nesting doll, artificial intelligence. This is the broadest, most overarching umbrella term we have. AI is simply the ultimate goal. It describes any computer system that can imitate human cognitive functions. Whether that's translating a language, figuring out if a product review is positive or negative, or making a decision based on past experience, if a machine is simulating human intellect, it lives right here in this massive outer layer.
Now, let's pop open that doll and look at the next layer inside, machine learning. If AI is the goal, machine learning is the how. It's basically a subfield where we teach a computer system how to do something by training it to identify patterns in data. Think about it like this. If you want to flawlessly sight-read sheet music, you practice your piano scales 10 million times. Well, that's exactly what machine learning does. It runs data through algorithms over and over again, getting feedback every single time, so it can start making highly accurate predictions without us needing to explicitly program every single little rule. Open that one up, and inside machine learning is an even more advanced, specialized doll, deep learning. And the leap between these two is absolutely profound. In classic machine learning, human experts still kind of have to hold the computer's hand. Like if we wanted to recognize fast food, a human literally has to manually label a bunch of images with tags like pizza or burger to structure that data. But deep learning completely changes the game because it automates that feature extraction. You can just feed it a massive mountain of raw, unstructured, unlabeled data, and the system is actually smart enough to figure out the defining characteristics of a pizza versus a burger entirely on its own. Section 2. Inside the digital brain, neural networks. So you might be wondering, what exactly gives deep learning this incredible autonomous power? Well, to understand that, we have to look at neural networks. And this architecture is directly inspired by how our own biological brains work. A neural network is essentially made up of layers of artificial neurons, or nodes, that are all connected to one another. Each of these connections has a weight, which basically determines how strongly a certain input influences a decision, and a bias that acts as a sort of threshold. By constantly tweaking and adjusting these weights and biases across millions of connections, the network learns how to map inputs to accurate outputs. It's essentially a simulated digital nervous system.
Section 3. The Generative AI Boom.
Now, all of those neural networks and deep learning models have culminated in something truly revolutionary. And this is where things get genuinely fascinating: generative AI. For a long time, AI was mostly analytical, right? It could sort data, maybe recognize a face, or pull up some search results. But generative AI is a whole different beast. It leverages deep learning to actually make things. It learns the underlying patterns and structures of language, or art, or code, and then uses that understanding to generate something completely unprecedented. It's not just regurgitating some old Wikipedia article, it's crafting an entirely new story, a brand new image, or a fully functional piece of software right from scratch.
The engines driving this crazy text generation are called large language models, or LLMs. Let's quickly walk through the 4 steps of how they actually pull this off. First up is pre-training. This is where the model just consumes billions, even trillions of words from all over the internet. Second is tokenization. It chops all that text down into tiny machine-readable chunks called tokens. Third is where the real magic happens. The transformer mechanism processes these tokens to truly understand the context. And finally, inference. The model basically acts as a giant, superpowered statistical prediction machine, mathematically guessing the absolute most likely next word in a sequence, over and over to write out a sentence.
I want to pause on step 3 for just a second, because the transformer model, which was introduced back in 2017, is literally the secret sauce of modern AI. Before transformers came along, AI really struggled to remember the beginning of a long paragraph by the time it reached the end. But transformers use this brilliant mechanism called self-attention. This allows the model to constantly weigh the relationships and the dependencies between different words, no matter how far apart they are in a sentence. It actually grasps context and nuance, which is exactly why AI suddenly sounds so remarkably human these days. So how do we humans actually interact with these incredibly complex prediction machines? Through prompting. A prompt is simply your specific instruction to the AI. I always love the analogy of placing an order at a deli counter. You don't just walk up to the counter and grunt, "Give me food." You specify the exact type of bread, the specific meats you want, the exact amount of cheese, your preferred condiments, all to get that perfect sandwich. Prompting an LLM is exactly the same concept. You've got to design clear, specific, and contextual instructions to guide the AI toward the exact output you're looking for.
Section 4. Capabilities, Limits, and Future.
Okay, so now that we've peeled back the nesting doll and we understand the mechanics, we really need to ground all this hype in reality by looking at where these systems actually fail. Because LLMs are fundamentally just predicting the next most likely word, they have a pretty critical flaw: hallucinations. Sometimes an AI will just generate completely false or misleading information, but it will deliver it to you with absolute, extreme confidence. Why does it do that? Because the system doesn't actually comprehend truth. It literally can't tell the difference between real and fake data. It's exactly like if you looked up at the moon, saw the crater outlines of a face, and started insisting with total certainty that an actual man lives up there. We have to be incredibly vigilant about the accuracy of these models. It's also super helpful to categorize exactly where we are on the evolutionary timeline of AI right now. We can divide the landscape into 3 main buckets. We have artificial general intelligence, or AGI, which would match human intellect across all tasks. Then we have artificial superintelligence, which would actually surpass human intelligence. But if you look at the status column, AGI and super AI are entirely theoretical. They belong squarely in the realm of science fiction for now. Every single AI tool that exists today, from Siri to ChatGPT to the self-driving cars on the road, is narrow AI. They are incredibly powerful for sure, but they're still considered weak AI because they are strictly limited to completing specific, predefined tasks. However, even within that narrow AI bucket, we are about to take a massive leap forward. The immediate next frontier is something called agentic AI. We're moving way beyond basic chatbots that just sit there idly waiting for your prompt. Agentic AI refers to highly autonomous systems that can actually design their own workflows. Imagine just telling your computer, "Book a vacation for me." An agentic AI won't just spit out a list of links. It will independently research the flights, navigate the booking websites, securely use your credit card to buy the tickets, and reserve your hotel room. It coordinates multiple steps and uses different tools entirely on its own, without you having to intervene at all. Which brings us to arguably the most crucial question we face today. As these technologies evolve from passive chatbots into highly autonomous systems, the stakes get significantly higher. Think about it. Who is actually accountable when an autonomous agent makes a major mistake? If it's out there acting on our behalf, how do we make absolutely sure it's doing so responsibly?
As we orchestrate this increasingly autonomous agentic AI, are we actually prepared to implement the ethical guardrails required for our digital future? It's a massive consideration for every single one of us as we continue navigating this journey. Thank you so much for joining me on this explainer, and keep exploring.